depending on the claim. Okay. 3 ways to set up the null and alternative hypothesis depending on the type of claim. If it is this type of claim, if it is this type of claim with greater than, so this one does not equal to, this one is greater than, and the other one less than. 3 different types. Okay, so here it is. I'm going to try to put all of them together. So, as an example, P equals some value from the past. The alternative, P does not equal some value from the past. This is a two-tailed test. When we get to do that, then we will know exactly what it means. For the same, I'm going to keep the same type of example with proportions. P equals some value from the past, and the alternative, P greater than the number from the past. That's our claim. This is a one-tailed test, one-tailed test, and it's specifically a right-tailed test. Of course, the last possibility, the alternative does not change in all 3 situations, but the null hypothesis, but the alternative this time is less than P0. This is also a one-tailed test, and of course it's a left-tailed test. So by some value from the past, I gave the example of P sub 0, any number. Of course, between 0 and 1, because we're talking about proportions. Okay, so now I would like us to go back to example 1. So I'm at the top on page 3, at the very top. It says go back to example 1 and identify the null and alternative hypothesis. And now I need an ES. LS, as well as the type of test. Okay. Back to example 1. In example 1, we have P equals 0.62. And he believes that the percentage is different. We already wrote this. All I would like to add here is this is a two-tailed test. Two-tailed test. The next one with the mean. So the mean equals 3.25, and the mean has increased. This is a one-tailed test, specifically a right one. Right, because we are that way. We're going that way. Right-tailed test. And the last one, because it says again, has increased, I'm not going to write it one more time, is the same thing. I can, so it's 0.23, and sigma greater than 0.23. It's the same thing with this one, same. Any questions so far? Okay, more examples on determining the null and the alternative hypothesis, and if we are facing a two-tailed test, a left-tailed test, or a right-tailed test. So let's start. This is example 3. The Medco pharmaceutical company has just developed a new antibiotic for its children. Fine. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the FDA, Food and Drug Administration, wants to to know if the percentage of children taking the new antibiotic and experiencing headaches as a side effect is more than 2%. Can anyone tell us what is the null hypothesis? What is the claim? What is the alternative hypothesis? What do you think?
If I could see the paper, I'd tell you.
This one?
Yeah.
A researcher wants to know if the percentage of children taking the new antibiotic and experiencing headaches as a side effect is more than 2%. What will be the
Really blurry when I'm trying to see it. So I'm sorry.
So what will be the first of all the null hypothesis here? This is a null hypothesis. This was known from the past. And now we have to think about the claim. What is the claim?
More than 2%.
Very good. This is the claim. And this is the alternative hypothesis. Is it a one-tailed test? Is it a two-tailed test? What do you think?
Is it a one-tailed test to the left?
This means to the right. Exactly. One-tailed test, or it's sufficient. You don't have to say one-tailed test. I was asking, but it's a right-tailed test. This is good enough, and it's obviously clear that this must be a one-tailed test. If it's left or right, it must be one-tailed test. Very good. Moving on to the second problem. Any questions on this? Anyone? Very good. This
So
is
those
yes.
Those are the answers for those questions. Like those are considered done. We don't have to do anymore.
That's all. Yes, for now. Oh, there is more. There is much more work. For now,
Gotcha.
yes. For now, we are only asked determine the null, the alternative, and state whether the test is a two-tailed test, left-tailed test, or right-tailed test. For now,
Gotcha.
oh yeah, the calculations come in the next section, in the next two sections actually. A lot of calculations. But for now, we are just looking at the language. We are trying to understand what type of errors we can make when we perform hypothesis testing. We try to understand which one is, this is extremely important to understand which one is the alternative, which one is the null hypothesis, and what type of test we are conducting. Yes, there is more, way more to it. Okay. Problem part B. The Blue Book value of a used 3-year-old Chevy Corvette Z06 is $56,130. Grant wonders if the mean price of a used 3-year-old Chevy Corvette Z06 in the Miami metropolitan area is different from $56,130. One more time, the Blue Book value from the past experience is $56,130 if it's a 3-year-old. So here's the claim. Is it different? We're wondering, is it different? Is the mean price of a used such and such different today? Can anyone identify the null hypothesis and the alternative hypothesis? We're not talking about we're not talking about proportions. We're talking about mean. So,
It says
yes,
that the null hypothesis is 56,130.
the mean equals 56,130. Very good.
And the alternative hypothesis is different from the
Excellent. Very good. Thank you very much. That's it. That's it. The null hypothesis is the information from the past. This is our claim, whether it is the same or not. What type of test is this going to be?
Is it a two-tailed test?
Excellent. By two-tailed test, you will have tails in both. Yep, very good. Part C. The standard deviation of the contents in a 64-ounce bottle of detergent using an old filling machine is 0.23. The manufacturer wants to know if the new filling machine has less variability. So the manufacturer wants to know if a new filling machine has less variability. The null hypothesis and the alternative hypothesis.
Would that be HO equals sigma 0.23,
Very good.
and then HA equals sigma less than 0.23?
Excellent. What type of test is this?
Right-tailed? Or no, that would be left-tailed, wouldn't it?
Yes.
Yeah.
Excellent. Moving on. Page 4 of the handout. Now, there are 4 possible outcomes for hypothesis testing. First of all, what could the results be? So maybe we should just write a couple of results here, possibilities, before I explain, just move on into the error type. So just the last one that we have here. What could the conclusions be? And then we can go back to the other ones. So after I conduct the test, this is not the test. This is just the beginning of the test. When I establish what the alternative, the claim or the alternative hypothesis with the claim and the null hypothesis are, and what type of test I'm going to conduct. And there is a lot of work for conducting the test, but assuming we completed the test. So now the question is, what conclusions can I draw? Here are 2 possible conclusions. And these are the only ones, actually. Reject the null hypothesis based on the sample I got, on the sample info. What is the other possibility? Fail to reject. The null hypothesis, of course, based on the sample info. So then what can happen here? 2 things can happen in both situations. I am correct or I'm wrong. I am correct or I'm wrong. So if I reject the null hypothesis, I could be correct, and then there is no error, right? If I reject the null hypothesis and I should reject it, then there is no error. But if I reject the null hypothesis, but I am wrong, then I make an error. I shouldn't reject the null hypothesis. Okay. What can happen here? I fail to reject the null hypothesis. I'll say the information coming from the sample still supports the claim, still supports the information from the past. It does not support my claim. I collected a legitimate sample. I could not show that the standard deviation is less than this because the sample information was still supporting the original or old claim. So I fail to reject, and I may be correct. I can't reject. The data coming from the sample does not support the claim. Or I could be wrong. I will fail to reject, but I should be rejecting. So these are the 4 possibilities that you see here. Reject and I'm correct. Reject but I'm wrong. Fail to reject but I'm correct. And fail to reject but I'm wrong. So 1, 2, 3, 4 are these possibilities here. Like with any decision, should I buy a car or not? If I buy it, I could be correct or I could be wrong. If I don't buy it, I could be correct or I could be wrong in my decision. Same thing here. So I summarize this information in this little table. So I can reject the null hypothesis when I should. So I rejected the null hypothesis, and I'm correct. I should reject it. Then I don't have any error. I'm not making any error. When I reject, and I'm correct to reject, I'm not making an error. I reject the null hypothesis when I should. No error. When I reject the null hypothesis, but when I should not reject it, I do make an error. So I reject the null hypothesis, but I should not. I'm making an error. This is called type 1 error. Type 1. And that is alpha. What alpha? The alpha that we know from our past few weeks. I'll come back to it. Fail to reject the null hypothesis when I should not reject it. I didn't reject it and I shouldn't reject it. There is no error. But if I fail to reject the null hypothesis when I should reject it, then I'm making an error. So I fail to reject the null hypothesis and I'm wrong. I'm making a type 2 error, which will be denoted by beta. Like in life, every time here with the experiment and the hypothesis testing, every time I make an error, I make a bad decision, I make an error. If it's a bad decision, if I'm wrong, I make an error. It was a bad decision, I made an error. Type 1 error, which is alpha, is chosen by us from the very beginning. It's our level of confidence. It's our level of significance. Level of significance. As type 1 error increasing, the type 2 error decreases and vice versa. Now, what I would like to do next is identify what is the type 1 error and what is the type 2 error in one example here. So, this could be confusing, but as we know, every time we make an error, every time we're wrong, we're making an error.